As the last talk in this session, there will be a talk on freenet, next generation. Probably most of you know freenet in its earlier generation, back in '99, first anonymous secure network, peer-to-peer. And now it is my pleasure to introduce to you Ian Clark and Oscar Sandberg, who are the originators of freenet and its next generation, and welcome. Thank you.
Thank you very much. So my name is Ian Clark. I'm the founder and coordinator of the freenet project. Freenet's something I've been working on since about 1999. This is Oscar Sandberg, who's our resident mathematician, or semi-resident mathematician. And the work we're about to describe is a collaboration between Oscar and I. And it represents what will be the next version of freenet. So we've been in the peer-to-peer business pretty much as long as there has been a peer-to-peer business. Well, let me talk about the goals of freenet first for those who are not familiar with it. The goal of freenet is to allow people to publish and consume information anonymously. It's primarily designed for people living under repressive regimes in countries where the internet is quite heavily censored, particularly situations like China, where the path between points inside China and points outside China are monitored and controlled by a firewall. But freenet also has its uses in Europe and in the United States in situations where people are unreasonably trying to limit people's ability to communicate freely. The original design of freenet, and I'll talk a little bit more about this, but the original design was basically anyone could join the network. The algorithm that we use would select people for your computer to talk to, and through those connections you could push information into freenet or you could request information from freenet. And the most popular user interface for freenet actually is just a web browser. We set up a HTTP proxy through which you can request information from the freenet network, and it just gets displayed in your web browser. However, what we have realized over the past few years is that when the act of participating in this kind of network in itself can cause people to get into trouble, the current architecture used by not just freenet, but pretty much all comparable anonymity networks is not sufficient. The reason is that if anyone can just connect to anyone else, then how do you know that the person you're connecting to isn't the Chinese government or the state police? And if you connect to them, or they connect to you, then they know that you are participating in the network, and that in itself could cause serious problems for you. So we realized that in the future, for an architecture like this to be truly robust in a situation like China, or even in the United States with some of the court decisions that are now coming down with respect to peer-to-peer software, we would need to adopt a more closed approach whereby people only connect to other people that they trust, to people that they're okay with knowing that they are participating in the network. One word for this is a friend-to-friend network, or a darknet. The terminology is still kind of evolving. So taking a step back, what is a peer-to-peer network? Well, you'll almost get a different definition from everyone you ask, but probably the things few people would disagree with is that a peer-to-peer network is where you have information that is spread across many interconnected computers. Users of the system want to find that information. How do they do that? Well, the simplest peer-to-peer networks and the first peer-to-peer networks, for example, Napster, had a very simple approach to this, which was that you have a central database which knows where everything is. And so if you want to retrieve a particular piece of information, you contact this centralized database. You say, here's what I'm looking for, where can I find it? It tells you, and then you contact those other peers directly and request the information from them. Some approaches, the problem with that, by the way, is that if you rely on a central company or computer, then it can be shut down very easily or blocked. And indeed, that's exactly what happened to the original Napster. Some peer-to-peer networks are semi-centralized. The most popular example of that would be Kazaa, whereby instead of having just one central point, you have many of these central databases which know where to find content. So if you want to find some content, you basically contact your nearest super peer and they will tell you where to get it. The problem with that approach is that it has limited scalability. You're only going to be able to find information if the super peer or super peers you talk to happen to know about it. So it has a search horizon, is another way to describe that. Other peer-to-peer networks are completely distributed. Freenet's an example of that. It's completely distributed in the sense that all peers are essentially equal. We don't have some peers that are responsible for keeping track of where information is, and other peers are just essentially clients. All peers do essentially the same job, and they all collaborate with each other in order to allow you to find information in a hopefully scalable and robust way. There's another way you can kind of break down peer-to-peer networks, which is will get us onto what we're describing here. Light peer-to-peer networks, which basically almost all peer-to-peer networks we would describe as light peer-to-peer networks. A light peer-to-peer network is a network where anyone can connect to anyone else. You sign up to the network, and depending on how the algorithm used by the peer-to-peer network works, you can end up talking to anyone. It doesn't care. It's effectively promiscuous. The advantage of this, well, it's relatively simple to implement, provided you're using the right routing algorithm, the right algorithm to allow peers to find the information they're looking for. The disadvantage, it's vulnerable to what we call harvesting, this process whereby someone that you don't want to know that you're part of the network can find out that you're part of the network and perhaps punish you for it in some way. The other alternative is dark or friend-to-friend peer-to-peer networks, where peers only communicate with other trusted peers. The only real working example of this that we're aware of, I think, is a piece of software called Waste, that many of you might be familiar with, where only the people you trust know that you're part of the network. But the problem with Waste and the Waste kind of architecture is that if you can only get information from your friends, then Waste peer-to-peer networks tend to be small and isolated, which really isn't terribly useful for the type of things that we want to do, because we want to allow people to share information with anyone else that's interested in it, not just with the people they know directly. So how does a peer-to-peer network like freenet, or peer-to-peer or distributed hash tables, which is another class of peer-to-peer application, how do they find information in a decentralized, scalable way? Well, they rely on a principle that you're all probably familiar with, the small world phenomenon. This will be, you may have heard of the 6 degrees of separation, the fact that you can get from any one person in the world to any other person just by going through personal acquaintances. The reason that works is that human relationships form a small world network. This was quite graphically demonstrated in the 60s by a guy called Stanley Milgram, who demonstrated it by, in the United States, took a bunch of letters, several hundred I think, put the address of somebody in Cambridge, Massachusetts on those letters, and gave those letters to a bunch of just random people, I think in Kansas and some other Midwestern states. And the instructions were, you've got to get this letter to the person whose address is on the letter, but you can only do it by sending it to someone you know personally. And they need to send it to someone they know personally, and so on. And what he discovered, quite amazingly, is that these letters not only found their way to this guy, but typically when they did so by going through, I think it was an average of about 6 or 7 people. So you've got a country of 270 million people, and this simple routing algorithm in a totally decentralized way, just relying on personal relationships between people, was able to get from one person to another in just about 6 steps. Very powerful, very scalable, and very robust. If one person decided to be malicious and send the letter to someone completely unrelated, then it would actually it would basically restart the routing process, and it would take a little bit longer, but not significantly longer. So very robust against failure as well. And this is the basic principle that most totally decentralized peer-to-peer networks rely on in order to find information. The thing about a small world network, though, is you've got a bunch of people, or more generically, you've got a bunch of nodes, and some of them are connected to each other. But even though small, short paths between pairs of nodes might exist, that doesn't necessarily mean that you can find them. In the case of human relationships, if you think about what those people were doing, they get a letter, they look at it, they think, Cambridge, Massachusetts, I have a friend who lives near Boston, I'll send it to him. So they're routing on the basis of who do I know is most likely to know this guy, and to make that decision, they're relying on geography, they might think about profession, a whole load of rich information that people have that allow them to route effectively. So that's how people find short paths. But that's not necessarily so easy for computers. In order to find these short paths, you need a concept of similarity between nodes in your network. You need to know that, well, you're trying to get to this guy in Cambridge, Massachusetts. You know this person who lives near Massachusetts, therefore they are close together in a certain sense. It also needs to be the case, and this is somewhat self-evident in the example I've just given, but peers which are closer together have to be more likely to be connected to each other. The whole reason that you send something to your friend in Cambridge, Massachusetts is because since he lives closer, he's more likely to know that guy or know somebody who does. And so the algorithm in this kind of small world network is extremely simple. At each step, you just think, who do I know is closest to the destination I'm trying to get to? And that's who you send your letter or request for information or whatever it happens to be to. We call this approach greedy routing. So this is the basic principle that freenet and distributed hash tables rely on.
Okay, so what we're dealing now is with the second generation networks, where we want to build this dark network that Ian described in the beginning. We want to build a network like freenet, but we want it to be possible for people to only have to communicate with their trusted friends in the network. In order to do this,